So, looks like we are live now. I hope everyone can see it running. At least I can. Great. So then, welcome to the stream. Today's stream will be a lot of fun because we will catch up on where we left last week. So basically building some MCP stuff. And today is less about the model context protocol. It is more about dealing with Automerge CRDTs and trying to build actually a package manager. So the idea came up last week already, and this week we want to continue on that. So let's start with a little catch up on where we left last week. So, wait, wrong computer. So first let's switch. So let's switch to where we actually left last week. So this is basically the idea that we came up with last week and that we prototyped a little bit in Python. And when we look into that, the concept is still the same. You know, we have a tool like Cloud Code, which is a coding agent, and there is a context for the model, for the LLM, that Cloud Code actually creates and maintains, which is basically the whole purpose of the agent, to create this context and provide it to the LLM. And to do that, it gets tools and other stuff from it can get them via the MCP, the Model Context Protocol, from some external things. We looked quickly into that. We used prompts, we used resources last week in a quick demo with Python. And the idea is basically to build a package manager for this model context. So similar to, let's take an example. Let's say you have your TypeScript application. Of course, you don't put everything, every dependency that you want to use as a single dependency somewhere. You do not download them and put them then on your in some special directory or so in your project. Of course, you have your package.json and you declare them there. And then you run npm or one of those other tools and get this all installed. And we want to do something very similar. But the difference here is that we don't want to provide these packages as just plain files, you know, because the cool thing is with the Model Context Protocol, we have a way to provide them through some protocol which has defined resources and defined things like the prompts, or resources is actually a direct term there. So that's pretty cool. We have the Model Context Protocol to do that. So this is basically like, think of it like if npm could just, or some other tool could just use something, or no, better, let's say the TypeScript compiler could just use some protocol to include some code from some packages. This is quite similar here. So the idea is to have then documentation and tooling there, maybe some other MCP servers being proxied or whatever. You could do a lot of things, you know, similar to what you could do for a project with npm. And if you think, and the reason why we do that today is basically, if you think that idea a little bit further, then you realize that you can actually have dependencies here, you know. So let's say you're using a framework like Next.js and or anything else, Ruby on Rails or whatever, you know. Your framework, of course, there's a set of documentation and instructions that you want to provide to Cloud Code or another agent. And this set of instructions is just very specific to how Next.js works. So you can simply include documentation, instructions, and maybe even prompts specifically for Next.js through the MCP protocol. So you can just add this to your project and say, okay, this is a Next.js project, so add the Next.js package here, and then I have these instructions here. And the cool thing is you can then combine those packages as dependencies and share them with your colleagues. So that's roughly the idea. But we will do something different here to traditional package managers, and that's what I would like to show you quickly in this video today. So let's start. First, what we usually have in a package manager is we have something like a package config or something like that. So if you use a package manager, let's take, for example, the Rust package manager. So there is, I think it's uppercase. There's a cargo.toml file in that repository, and this declares then some dependencies and whatever else you want in your Rust project. And what Cargo usually does is it will download the dependencies. So the dependencies declared in your Cargo toml are downloaded by Cargo when you run Cargo whatever, so it happens automatically on the fly. And they download them and then put them somewhere. So in Node.js, you usually have your node modules where your packages or your libraries get installed. In Cargo, I don't actually know exactly where it's installed, in some cache probably. And then it gets used during compilation time. Each package manager has the rules there. Take, for example, UV in Python. It usually creates a virtual env, which is a very Python-specific way of doing things. And then you have usually a .venv directory in your project where everything is set up. And UV as a package manager takes care of managing this virtual environment. So each package manager has a very unique way of doing things, but the general principle is you have a configuration of your project, and then you download the dependencies. And of course, your dependencies have their own Cargo toml, basically, to include actually metadata about itself. For example, the dependencies of the dependencies. So each dependency can have transitive dependencies as well. And then you can use them or not, depends a little bit on the setup there. I think there are programming languages that allow you to use dependencies that you did not declare, and there are some that don't allow you to do that. You have to declare everything explicitly, cannot just use the transitive ones by just inheriting them. Nevertheless, that shouldn't be our problem here. That's the usual way how this works. And then your project has all the dependencies included. So when they are downloaded, they are stored somewhere locally. And this can, for example, be in Node modules, or let's say in e.g. within the project, like we have this with node modules. So that's pretty straightforward. We can just do that. And we could do that as well when it comes to the model context, or the idea of model context package managing. So because in the end, this is just markdown files, isn't it? There's a little bit more than markdown files there, but roughly it's just markdown files. And markdown files are actually the reason why I'm trying to do something different here. Because if you think about creating those dependencies, how do you actually create those dependencies? When you download them, what you do is basically you download them from some registry where the packages are hosted. And how do we get them here? Well, what we usually do is we have something like GitHub Actions, some CI build, which I think this one is in the wrong direction. So we have CI builds that publish them to the registry. So we have here some publishing happening. Nice. So that's basically how we do that all the way in each programming language. So we have at the end another tool here, which is our Git repository. So somewhere there's a Git repository, and this Git repository is exactly not what I wanted. This Git repository is hosted somewhere, could be on GitHub or wherever you have that. Can also be GitLab, Tangled, or whatever you use there. And then your CI build takes the code from the Git repository, pushes it to the registry, and then from the registry you can actually download your dependencies. So all of that very straightforward. And if you want to change something on the dependency, because there might be something broken, or you want to change it actually. That's basically it. Let's assume you want to change it. What you have to do then is you create usually a pull request. Okay, that's a little bit hard. I think that's fitting better. So yeah. So if you want to change something, then you change the code. And then you provide a pull request. So I think that's better. So that's basically how it works. So you're declaring this, and to change things, you need to do a pull request with the changed code on that Git repository. If this get merged, there's a CI build running that will create a new version. Of course, there might be also something like a release process or something like that. But there is some way how this happens, and then it gets published into a registry, and we can declare the new version of the dependency, or the upgraded version of the dependency, and then we can use that new version. And it gets stored locally. We can use it, the compiler can use it, whatever. So that's the usual process that we are all known to, or that is known to us actually, and that we all know from working with code. And as great as this process is, Markdown files don't fit that well into it. So why is that? Actually, they do. Markdown files are text files, so we can just put them into the same Git repository. We can just use a pull request. All of that works quite well for Markdown files as well. And we can do that, and we can also have a CI build that publishes then some Markdown files to some registry, and we could theoretically download them with our package manager. This would work, but there is a problem. And that's actually Markdown files are not that great to version in Git. The reason for that is simply because other than code, markdown files are much more difficult to review, for example, and they sometimes have the problem with the same line. So you put a lot of changes on the same line, get some merge conflicts because everyone changed the same line. And that's just because the same paragraph lives on the same line. If everyone would write Markdown in a way of, let's say, maximum 80 characters per line, then of course things would be much easier, but that's not how it works. Most people are not doing that. So we don't want to force people to do that. But if we are writing more Markdown, maybe even let an LLM generate this Markdown, this will not become easier. So we will have probably more merge conflicts. It might be more difficult. It is at least a more limited thing compared to some TypeScript or Rust code. So what are we doing? Well, there is a solution to that, and that solution is called Automerge. So what is the idea behind that? The idea behind that is, or what is my idea actually here? So if we move this up, what is the idea I'm proposing or I want to try out with my package manager here is we do a repository. I don't know if we call it really a report. No, exactly. I want to call it a package. So we have a package, and that package is an Automerge document. So what does that mean? Well, Automerge is a CRDT. A CRDT is a conflict-free replication data type. I don't want to go too much here into the theory behind that, but the idea is basically, let's say you have two texts and you change the text and someone else changes the same text, you can still merge them without actually having conflicts or with actually having rules how to resolve those conflicts. That's probably better. So there's a lot of metadata about the changes stored. So it's definitely in the end more than just text that is stored in an Automerge document, but that's okay. It gives us the opportunity to merge things. So a very typical use case for CRDTs is that we run something like real-time collaboration. So think of it like, I don't know, let's say, today I read actually a very interesting case. So let's say you use Figma. If you use Figma to design something, you can share this document and then multiple people can just work on the same Figma document, or however this is actually called in Figma, on the same layout or whatever you do there at the same time. You can collaborate on this in real time, like you do with Google Docs, for example. So those kind of things you can build within CRDT because those things can be synchronized on the fly. But Automerge is not limited to synchronize things on the fly. Automerge can very well do that also if the merging happens delayed. That's totally fine. So you could think of it like, I have an Automerge document and I create a copy of it and give it to you. And now we both modify the document and then you give me your modified version and I just merge it into my modified version and it just works. That's what a CRDT does. The cool thing about Automerge is it supports, it is CRDT for structured data. So you can think of it like a JSON file that is merged, not like text, but as a structure. So if you add a key with a specific value to your JSON document, then in Automerge, this is an atomic change, not an update of a text. And Automerge also has support for text. So there's a well-known algorithm for CRDTs with text. So you can have a text field in Automerge documents and then use a simple, or then use this in the same way. So when two people change the same text, you can still merge this, which is pretty cool. And this is much easier to handle, I believe, I hope so, than doing all of that in Git. I know that Git is a well-known thing, but this is a specific setup that is outside of our normal flows. This is not about our code. This is about our development tooling here, which is a different thing. And I think that it requires a different type of tooling that is more powerful and more flexible. And this is where the Automerge document comes in. So the package is actually an Automerge document. And what we do is we can declare our prompts in it. So the idea is basically that we have prompts and that we have instructions and that we have also tools being declared in our Automerge document and in our package actually. And then we can put this whole package as a whole into a registry. So we could also have a registry. Let's see how we draw this best here. I think we also need something around. Let's make it, let's put it also into the back. So, and we don't want to, so this is the registry. And at the end, this is actually our Automerge document. So we want this. Okay. Actually, I want it here. Okay, that's not exactly what I wanted, but it will work. So we can remove that one. I think that works better. So we have prompts, we have tools, we have instructions, however we call this, and we put all of that together in an Automerge document. And we call this Automerge document a package. And then we upload this to a registry. So what we can do when we have a registry like that is we can download it. So we can say we have a tool that downloads a package. So we download the package, and when we have downloaded it, we can make it available, or its content available, as an MCP server. And the MCP server can be used by our well-known cloud code. So that's basically the way how it works, that or the way we want that. Of course, yeah, that the registry can actually download it, and then MCP can be used to make it available. So that's the rough idea behind that. We put everything into an Automerge document. Think of it as a big JSON that has versioning built into the JSON. Then we upload it later to a registry and can use it. We don't have to upload it to a registry. So it's a very easy to use approach, because you can just take it and share it as a document. But of course, as soon as it comes to dependencies, because that's also what we want, dependencies will probably make it much easier to deal with, or will be much easier to deal with if you have a registry where you can put that. So they need many companies would need probably a private registry or something like that, but that's roughly the idea. You could, in the end, put it somewhere where you have a HTTP or something like that. I don't know. How this registry looks like is nothing we want to talk about today. What I want to do today is I want to look actually into this part, and mainly into this part. So let's come back to where we were last week, and let's look into the code. So last week we created this tiny MCPKG project, and if you remember the stream from last week, it was a little Python POC to see if we can make things available via the Model Context Protocol. So if we look into the project today, it has changed a little bit. So if we have a quick look into it, it has now a cargo.toml, so it is a Rust project now, no longer a Python project. And that's actually the thing. If you look around, things like Dino, things like Gleam, for example, which is also a newer programming language in the Python world, the UV package manager, Cargo itself. So if you look around, the modern package managers are all written in Rust. I think it's a must-have that you write this in Rust. Of course not, but Rust is a good language to do that. It is quite efficient and creates small binaries. It's really great to build those kind of tools like package managers or something like that. It's an excellent language for that, especially since you don't need a runtime. So everyone can just install a Rust binary without having to install any Python or whatever runtime. So Rust is a pretty good choice for that, and I also like the language. So let's have a quick look into the project. So as I said, there's a cargo toml. You see here some dependencies are declared here, but doesn't matter that much. So it's also open source. I put this also on GitHub. You find this on my GitHub profile. And it's licensed under the Apache license. So you can also use that and change that. We have some support with Mise or I added some support for Mise, mainly for the npm, for getting access to, or for having Node.js installed, and use the Model Context Protocol inspector. We have seen that in the last stream already. We will see it in a second again. So we have an MCP server, and we want to use, obviously, the inspector to develop it. So the Rust project itself, it has a main function. The main function basically, well, it's actually a Tokyo main function. If you know Rust a little bit, Tokyo is the async runtime that everyone uses, or most people use. In our case, it makes a lot of sense because we want to download packages and stuff like that. So having async stuff makes a lot of sense. Also, the MCP SDK for Rust uses it already, so we have to get it because of the MCP SDK anyway. It calls the CLI, so we can quickly look into the CLI here. So this is just a normal Rust project with a command line interface. So we have some commands being declared, and we have a match on the commands to see actually to do different things. So the init command here is a dummy right now. The MCP command is the only one that works. And there is an MCP module. We can look into that one. It has a run function, which is also an async function. It creates a server with defaults, and then serves the server on stdio. So stdio is the stdio transport that is provided by the Model Context Protocol, and then it waits until it's done. That's basically it. So based on that, we are serving the MCP server this way. So if we look into the server, what is the server? It's basically a struct. That's how you declare a server. And you can, since we want to deal with prompts, you can have a prompt router in the server. You can then implement functions or methods on that server struct, and put this prompt router macro here on top. And this is quite a nice feature, because what this basically makes is, or what it basically does is that this example prompt function will be exposed as a prompt with the name example prompt to the MCP protocol. So you have, I don't have parameters here, but you could also add parameters here. You have some request context, and then you can return a message. So in this case, just a simple string, a static string that says something. And this, and the user, of course, what the role, you could also use the assistant here, for example. And then you provide this as a response. The server needs then to implement the server handler. You also have to declare that it is a prompt handler, which means it gets some prompt stuff being implemented as well. And the server handler is a trait that declares some functions. And in our case, we override here the getInfo, or we implement here the getInfo function. This is actually what is used during the initial call, initialized call in the Model Context Protocol. We can return server info and the capabilities here, which is quite important, because the capabilities are required to tell the MCP client that this server has prompts and resources. This is basically what we did last week as well. We had prompts and resources in our server. And for the resources, I have here this little read resource function, which gets the resource request param, matches the URI, and returns then, in this case, some dummy stuff. That's roughly it. So you can define prompts using this prompt router. And you can define resources and then have some matching on the URI here to return the right thing. That's how this whole Rust SDK works. Very similar to the Python one, although of course the Python one is a little bit, well, it's Python, it's not Rust. It's it was much easier and faster to get something running by that. But we can give this one a try. So let's have a look. As I said, we use the Model Context Protocol Inspector. There is a helper command here, means run dev. If we run that one, we see that this inspector starts. So this is the usual tool that you use to see how your stuff works. So you see we just run this via cargo. We run the MCP command. If we connect now, this is via stdio, should be pretty fast. I think if it's not fast, then it's because cargo is compiling the Rust code. But as soon as this is being compiled, everything just starts quickly. And you can see we have some resources. We can list them and see that we didn't get any resources. But at least we asked. And we have prompts, so let's list the prompts. We see our example prompt. If we call it, we get a message for role user, and the content is the static string that we. So basically it works. This is a tool we used last week as well with the Python MCP server. So that's how you do that when you do some MCP work, then you use that MCP server. So, or that inspector actually, which is a very handy tool. Great. So let's see what we want to do today. As I mentioned already, we want to use the Automerge CRDT. So this was the Rust SDK, and this was the basic idea. We want to create a package, which is basically an Automerge document, and we want to use that package actually to serve data to the MCP server. So this basically means that the MCP server, and that's actually the real thing that we want to build today, is that the MCP server needs to access this package. And it must not even read this. It must use that package. I think the text is not helpful here. So that's actually the thing that we want to build, this thing. So we want to create a package, and we want to create this arrow here where the MCP server uses the data from the package to do something. Very simple, isn't it? So if we look back to the code, what we see is that after the implementation of the server handler, the file is actually empty. And the main reason for that is because this is just some boilerplate code that I mainly copied from the Rust MCP SDK examples. We just renamed the server here a little bit, but the rest is the example prompt and so on. That's all copied. So why? And it's not exactly the implementation we had last week. So what's missing here at the end of our code is the tests. I didn't copy them. And so obviously this is where we also want to start with, to have some testing here and to get known how we do that. So we won't use Cloud Code too much today. It's more like hands-on stuff because I haven't worked with the Rust SDK that much yet, and I have no clue how the testing exactly works, and I still need to figure out how I make the SDK work in the way I want. For example, when it comes to the prompts here, it is a nice functionality that you can just put this this macro here to get the to make this function a prompt. That's awesome. Very, very nice behavior, but that's not what I want, because what I want is I have a package, and that package may contain a random number of whatever named prompts. So what I want to do here is I want to actually implement my server and the server handler in a way that I don't use that nice functionality because that's too static. I don't want to declare all the prompts in my code. I want to use prompts that are declared in some document, in some file, and I want to read them from there and want to set them up dynamically. We might later even look into changing them. So what if your colleague adds a new prompt and that gets synced automatically in the background to your computer and you get the prompt available? You don't want to restart the MCP. You don't want to start a new session. Instead, we could use the the model context protocol to notify the client about the updates on the prompt, and the client can learn, the agent actually can learn about the new prompt that has just been added, and then it can just use it without reloading any session or something like that. So that's of course for another session. We won't do that today, obviously. So, but yeah, that's the thing. We want to learn actually how this model context protocol works here, or this SDK in Rust works, so that we can serve the data dynamically. And we want to look into Automerge, how we can set up a proper data structure for a package and serve the data from that Automerge package, mainly in a test-driven way. If we are lucky, we get even to a point where we can actually look into this this CLI here. So right now we have the MCP command, which is obvious. We start the command and it will launch an MCP server. And the init command is not implemented yet, but it would probably just create an Automerge document with maybe some initial data. But we might also want to add things. So we want to make a package editable, and we want to do things here. Also, the model context protocol could be used for doing those kind of things. So also the agent could actually add a prompt. So we could ask the agent to generate a new prompt and then save it, or update an existing prompt with a new updated text or whatever. We could do all of these things at a later point in time. I don't think we will get this done today, but what we want to do today is actually learn how can we actually set up the prompts here in a more dynamic way, and how can we read them from an Automerge document and serve them. Okay, let's then start first with the model context protocol SDK. Because what I said already, I skipped the tests. I just got this somehow working and wanted to see that it works. But obviously we need the tests as well, because I'm a big fan of test-driven development and I want to use Cloud Code as well at a later point in time. So I need to understand this a little bit better so I can actually write some documentation for Cloud Code to do this in the correct way. And also I want to tell Cloud Code to do this in a proper way, which means in a test-driven way. So we have the counter STDI. Exactly. So within the examples folder here in the Rust SDK, so that's actually quite nice. Let's quickly jump into that. So if you look at the model context protocol page on the documentation page, you see there is a section SDKs on the sidebar. You can select this and find a couple of SDKs. So last week we looked into the Python SDK, which works pretty well and right out of the box, very nice for scripting and hacking. Really love it. But you also have them for Kotlin, for Swift, for Java, for TypeScript. There is even one for PHP, and you have one for Rust now as well. So there are SDKs, official SDKs available for several different programming languages already. So this means the Rust SDK is finally, we looked into that in an earlier stream that was still in development, but now it is already in a shape that it can be used very well. So within the SDK, we find here the examples, and the examples are all like that. So for example, there is a counter hyper streamable HTTP example. You always find in the example a main function, a Tokyo main function that does something. In this case, it uses hyper as an HTTP server to, I think it's the server side. Maybe it's the client side, I don't know. No, it's a server side. It uses Hyper as a server and Tower here to create a service on top of Hyper. And this is an streamable HTTP service, whatever this means. We haven't looked into the streamable HTTP transport, but yeah, it's just another transport. And then it uses some, where is it? Some actual MCP server. Doesn't. Here. This nice line is what we're looking for, counter new. That's actually the thing. If we follow the, no, we just go here. So we can look here, counter comes from the common module. So let's have a look into that, into counter. And that's actually the thing. In counter, .rs, we have the counter being declared. So you see counter is a struct like our server. And it implements, for example, a prompt router. So you have prompts being declared. And you see, actually, this looks pretty much like the example I copied, which is because I copied it from this file. So basically what you have here, and that's quite nice how these examples show this, you have here different MCP servers, and the counter example is actually a very simple counting MCP server. And you have those MCP servers, and then here in the actual examples, you just have the same MCP server being mounted in different ways on different transports, including authentication, without authentication, STDIO, whatever, memory STDIO. I even don't know what this should be. Memory data service, okay. Whatever this is. So if you're interested in that, feel free to have a look into that. We will just look into this simple example here right now, where it is all about the counter MCP server. So this is a very simple, well, actually it should be a very simple one. What you can see is that for demonstration purpose, they have created tons of tools here. Get values, say hello, echo, sum, and so on and so on. So it looks like this is not just a stupid counter that provides a lot of stuff, because in the end it's for demo purpose. So we have different things being declared here. For example, we already saw the read resources, but what I didn't copy is actually the list resources implementation here. And I think that's why we didn't see any resources, because the list resources by default returns an empty list resource result here. So probably an empty vector. But the good thing is there's also a test section here. And that's what I'm interested in right now. I would like to understand how I'm supposed to write tests for my MCP server, because I want to have tests for my MCP server. That's how things should be. So if you're new to Rust, this is actually how you do testing within, well, this is how you do unit testing, especially within your code, within your Rust file. On the bottom, you put in a module, a submodule actually, called tests, and you put this this config flag here on top. So only if the config test is enabled, this module here will be included. So if you compile the code for production use, so for as a release, this code will just not be included and not be compiled. It just doesn't exist. From a compiler perspective, only when it's compiled for testing. So that's why why you can do that in Rust, and it's a common thing that you put this just in the same function, in the same file actually as a submodule. So let's just do this easily and copy it over. And of course, we need to close it. And then, and we want to use the super package as well. We want to use everything from super. Because of course it's unused, but we want to use everything from super because this is a test. So obviously we want to do. And let's try to understand the test. So verify that the prompt macro generate the expected attributes. Okay, test prompt attributes generated. So what we do here is example prompt attribute. It has a name, description. Wait a second. There's also a generic service in it. I'm just curious what this I think the generic service maybe gives us a better understanding here. And of what we actually want to do. Let's just double check it. So we have a server handler that is implemented for generic service. Generic service is, where is it declared? I'm blind. Generic service is a struct as expected. And it has a data service. Okay, interesting. Whatever data service is meant to be. Where is the data service coming from? Okay, get data, set data. Okay, that's really interesting. But I'm more interested in, does the generic service actually create? No, it does not. So it also has a tool, get memory from service, tool, set memory to service. Okay, it's not generic in the way I wanted it to be. Good, so let's quickly go into the definition of our prompt driver. Okay, let's continue on the tests. So what we see here is that for the example prompt, the prompt attributes are created or generated with the right arguments here. But that's not really what I wanted to test. The test prompt router has routes. Okay. The prompt context. Here, test example prompt execution. That's actually what we're looking for. So we can say that we have a new counter. We have a prompt context where we say the counter, the example prompt, which is probably the name of the prompt we want to call. Then we define the message, which is a test message. Yeah, the example prompt here actually accepts arguments, So the one I copied without arguments, but in the case of the example here, it takes arguments, an argument message actually. So we create a map here and insert the message and some value. And then we have, so we have our counter, we have the name of the prompt, we have the we have an optional value or optional arguments. So we could also have, in our case, we probably have none here because we don't have parameters in the copied one. And then we have a request context with metadata, cancellation token, number or string. Okay, some ID. Appear. Okay, luckily there are defaults. An extension defaults. And now we have the prompt router. And we take the router and say get prompt from this context. This should be okay. Okay, so we can ask the prompt router from the counter, so from the MCP server, to get a prompt with a specific prompt context that we pass in and that we can just create. And then we can assert the prompt result that comes out of that. Looks very straightforward. Let's give this a try. And let's try to implement this ourselves. So within our tests, we want to this Tokyo test async test. What do we want to test? Test example prompt. Let's start simple. So as we have seen, we want to create a context. And this is a prompt context. Let's have another look. Prompt context. Oh, we want to create a new, just create a new prompt context with a server, a name, arguments, and context. Let's start with the name, because that's the easiest. The name is example prompt. And this should be a string, I guess. The arguments in our case, because I removed the parameters, should be none. And should be none. And the context is a request context. So also, no, there is no new. What was this? I'll just create the request context. The meta is just default. What else? I think we can just copy that one. Yeah, of course. Okay, Cargill at Tokyo. Let's see, Tokyo util. Let's see if this is good enough. Yeah, maybe we should start by also defining our server. And then we can also reference it here. I think that's how it's working, isn't it? Yeah, we reference it here. We provide the string. So now the only thing that doesn't work is, did they import anything else? No. The only thing that doesn't work is the request context. So what's broken with the request context? Ah, okay, there's still something. Let's see if it is our MCP. Here. Ah, now this one is gone. Mismatch types. Expected struct. Arc. But yeah, looks like they changed it actually. No, they did not. Did I miss anything here? No, that doesn't help as well. I guess I'm missing some detail. That's helpful. Okay, let's see if the compiler is right here. Default rate is not implemented here. Huh. That's interesting. The interesting question is, when did they implement this? So, what is peer? It is of type. Which one did we import? Request context. We imported the one in service. So this has a peer interface to fetch the remote client or server. Okay. Dun, dun, dun. What general purpose call peer send request or peer send notification? Send messages to remote peers. Here, send request. It's not really helpful. Let's see what we have here. It was the one in service, so we have the one in service. It has a peer. So if destruct no. Where's the struct coming from? If this struct now has default implemented, does not. Impl default for here. Okay. I think we are on the wrong track. Example. So this request context is coming from service here. It's exactly the one we're looking for. And trade for extracting parts from a context. Common extractor that can be used by both tool and prompt handlers. Super. That's not really what we're looking for, I think. Now, why does this not compile for me? Where is the little detail that I miss? What else can I implement here? Can I do something like peer? Yes, peer. Okay, one last try. So we are on a specific version. Let's see. We are on version 6.3. Counter. There were already tests. Ah, no. Also in that version, there's a default used. And this works as well. And I don't understand why. There anything imported that I just this one? I don't like that, but let's give that a try. That's weird. I don't understand this. It is really not clear to me why this example works. Maybe it doesn't, but it was like that already before. So let's check out the example. Something seems to be weird. So let's create a new, no, let's not create a new one. Let's just go over here. Let's oh no. If things are not working, let's try HTTPS. Rust SDK, neovim, find examples. What was it? We were looking into the counter. So the The counter stdio. Yeah, okay. Rust Analyzer needs some time. It needs to fetch all the stuff. So now we are in the counter. Here's our default. Why does this compile? Why does it compile? Although but not for me. What is the difference? Is it because I don't implement the rest of the tests or what? That would be weird. Let's continue on implementing the rest. Maybe that helps. So, what was the rest? The rest was basically that router equal counter. No, well, server prompt router. Let result equal router get prompt with the context, and we await it. Assert the result is okay. Okay, it's really, really weird, and I have no clue what's going on here. These are the moments where Rust can be very frustrating. I actually don't want to create a peer, to be honest, because the peer is actually no fun to initialize. I need a sender, request ID. Let's run airports. Let's run the tests. Let's try another test from the examples. Maybe we find a better one. Let's give this a notch. Examples. Let's say we have the generic service. There are no tests. Come on. The calculators. Also no test. Simple chat client. For whatever reason you want to do something like that. Ooh. At least there is no shit. Also no tests. Wonderful. I'm a little bit disappointed about the lack of tests here. Really would like be more on the testing side. Okay, maybe the docs can say something. Let's quickly jump on the docs. What does the documentation say? Let's see. The server tool client re-exports handler prompt handler. I think I have to solve the testing part later. And because otherwise we will never get anything done here. I will give it a try tomorrow again, or maybe next week, I don't know. But let's see. Okay. Let's revert that change. Let's go back to the documentation, because what we really want to focus on now is how can we actually make the prompt available from some dynamic content. So what we want is a macro. Yeah, so the prompt. So one step back. So what we actually want to do is we want to make the prompts available from an Automerge document or some structured data, but actually an Automerge document. So here's the here is a couple of macros. So we have the prompt handler actually. So the prompt handler generates a handler method for get prompt and list prompts. We have seen that in an earlier stream when we looked into the MCP documentation in the specification actually, that there's get prompt and list prompt, which are the two prompt related methods defined in the protocol. And this is what the inspector also does. You call the inspector, you open the inspector, call list prompts, and then you can select one to get a prompt, basically to read what's in the prompt. So a prompt handler can generate these two functions by using a prompt router. The interesting question is what a prompt router is. So I have my prompt handler, yeah, that's my server. And here I can now implement the prompts. And so let's quickly look into the code, what we have here. So we have our prompt handler here. And that prompt handler macro says my server needs to provide a prompt router, and then it can use that prompt router to do something. So that's exactly what we do. We have declared here the prompt router. And that prompt router returns now so we have declared a prompt router that is initialized using some prompt router function, which is this one here. And that prompt router function is basically implemented by using this macro here. So this macro will actually create a prompt router that routes specific prompts to specific functions based on their name. So theoretically, we could have a different prompt router, our own custom prompt router implementation here being set, and that implementation could then do something else, whatever prompt router exactly does. We will figure this out. And then our custom implementation can, instead of using the hard-coded or instead of using prompts that are implemented as functions in the code, we can use prompts that are loaded from an Automerge document. This makes a lot of sense. So it looks like the prompt router is the right place to look into. Let's see what the prompt router macro does. This macro generates a prompt router based on functions marked with prompt. Yeah, that's exactly what we saw. We have something marked as a prompt, and it will be exposed as a prompt within the prompt router. And this happens by declaring the prompt router here. So this is something we want, but not like that. So what we want is actually, where do we find, we want a prompt router. Why isn't this linked here? No. Now we have the don't want to use the macro. The modules, that's what we're looking for. Modules. What exactly is this prompt router coming from? That's coming from router prompt. It's coming from handler server. Okay. We have handler server prompt. No, router. Router prompt. There's also a tool router. Nice. Prompt router. And what is it doing? A prompt router gets initialized with routes. So we can create a new prompt router, or we can create, no, we can create a new one. We can merge them, add and remove routes. Oh, that's nice. We can ask it if it has one or has a route. And we can call list all and get prompt. So basically, the trick is to implement this and have a prompt route for each. So what are the prompt routes? It has a prompt handler. Oh. And an attribute prompt. What is a prompt? It has a name, it has a description, it has an optional set of arguments. Very good. So now that becomes quite clear. So what we can do is we can create a prompt route with some handler. I would say the handler is kind of generic because the handler is probably, so how would this look like? We would probably say we have an Automerge document. Within the Automerge document, we have a key value attribute, or we have an attribute prompts, which is a list of prompts. Each prompt basically looks like that. It has a name. It has an optional description. It has an optional list of arguments. So prompt arguments also have name, description, optional description, and an optional flag if they are required. And it has a handler, which in our case is not a handler. What we want is that our prompts basically contain some text, something that the prompt should basically return. So this can be either a template, or this can be some plain text. So we could say the content of the prompt in our case would then have a content. Let's write this actually down. So let's create a new markdown file. We will not commit this one. It's just for taking some notes here, doing some quick stuff. How would this look like? So we have prompts in Automerge. And we represent this basically as a JSON. So we get this, because basically an Automerge document is like JSON. So what we would get is something like, that's the wrong key, something like this. Then we have prompts. Then we have a list of prompts. Every prompt has, first of all, it has a name, which is some example prompt. Then it can have a the description. That can be something. Let's not care about that. And it can have arguments, which on their own would then be an array. For simplicity, we leave that array empty here, but these would be argument objects with a name, description, and so on. All of that. And then we would have the content of that prompt, which would be an object. And that object has, the content has a type. As a type, this could be text markdown, could also be a template. And then it has some value, create something nice. So let's say our prompt in Automerge looks like this JSON roughly. We skipped a few things like the arguments, but that's basically it. So let's say our package, our that we want to build here on our our model context package is an Automerge document. It contains a prompts key, and the prompts key has this type of a list with different prompts, each with a name, description, arguments, and the content, which itself has a type. And the type is important because then we can actually say this is a text that we return, or it is a template that we use. So we could basically define a template engine and or use a template engine, something like I think in Rust, Mini Ginger would probably be a very handy thing for use here. And then we could use these Mini Ginger template engine to create actually, or to use templated prompts as well. Because in the end, if you have arguments, you need those arguments to be reflected in the prompt as well, because, well, you cannot do it otherwise. So this means that our MCP server would then go and we would remove this prompt router section here. So this section would go. And instead, we no longer have the prompt router here. So instead, we would define impl prompt router server for server. And then we can look again into the prompt router. So no, we don't have to do that for. I'm wrong here. Just implement it like okay. Yeah, that's fine. So we implement this for this server. And we have now, there's different functions here. But wait a second, we don't have to. A prompt router is already a struct. That's even better. That's also not what we want. What we want is actually a function load prompt router, something like this. So that would probably take some input, however the input looks like. Could be an Automerge document or something like that. And then we go and create a prompt router. Let prompt router be a prompt router new router dot with at with this returns the prompt router again. Yeah, we don't need that. So prompt router at prompt root new what is the new method doing? It has an attribute. Okay. It takes something that becomes a prompt and a handler where the handler is defined like that. Mhm. Okay. So the attribute is a new prompt. That prompt new with name example prompt. Description is in our case we actually don't need a description. I think the description is an option anyway. Yeah, let's make it simple. Let's just pass in none here. Also, the arguments can be none. We want something working. So now we can pass the prompt here. Using the limiter. Exactly, the handler needs to be defined. This is an interesting one. So it is an arc didn't get prompt handler. Dynamic prompt get prompt handler. So type alias for. Oh my god. Okay. How do I create this? Type alias for dynamic prompt handlers. Dynamic for a function prompt context. Now to future of a result. Okay. And the S parameter, prompt route S. The question is what the prompt router is also S. Okay. So this is then the server. This is also the server. Why do we need the server here? Because of the prompt context. Okay. So we have a function that takes a prompt context and gives basically, we have an async function that returns a result of a prompt result. So then let's give it a try. So let's say we have a sync function handle example prompt that takes what get prompt, no, a prompt context get prompt and only a prompt context. Prompt context. And it returns a result of get prompt result. And error data. I think I imported this as MCP error. Wonderful. A nice copy from the example. So what are we doing here with this now? So we have created the prompt. We have now a handler. Let's create a let result get prompt result. So what can we do? No. Then let's just create one. Whatever goes into the prompt results. Description. Obviously a description. Let's see. So description and messages. A vector of prompt messages. Which of course is not just, I don't know. It can be multiple things. Sure. New resource link. Okay. It can even be much more than I expected. So we have a prompt message role. No, we have, first of all, we have a description that is optional. Okay. Description. None. And we have messages, which is a vector. Let's just keep it empty. And then we just return them. You know, that's the easiest we can do. But we have to wrap it into an OK. We're currently not using that one. Looks like there's still something missing. Yeah, prompt context. A 5 times. I love them. As long as I don't have to deal with them. Use of undeclared name A. Function. Which key is it? Come on, how to declare the lifetime on a function? Ah, okay. Position. So, what I would like to do is now to say something like this. Handle example prompt. But this didn't work, of course not. Maybe like that, also not. Ooh. Okay, so where are we today? We are already 2 hours into the stream. We are not close to loading from Automerge. And I think I have to figure out how this handle thing in Rust actually works. But that's probably another rabbit hole. So for now, I think we will close the stream for now, just because this will not work out immediately. Yeah, but that's how it is. So thanks for visiting. Thanks for watching, actually. I hope you learned a little bit, or enjoyed it at least. And we will continue on that, but probably not exactly on that case. But we will definitely continue on the package manager and see where this is going. So if you're interested in getting some more Rust coding, next week on Monday, same time, I plan to be here again. So until then, enjoy the rest of the week, and